Welcome to Winning Edge. Today we will discuss P block elements. In particular, in P block, we will discuss about group 15, 16, 17 and 18 elements. P block, which is also called representative group of periodic table. The importance of P block elements is humongous and beyond any comparison. We know life existing on our planet is nothing but basically hydrocarbon chemistry. So carbon is a P block element, sulfur, phosphorus, nitrogen, which makes a major part or skeleton of life. All are P block elements. Oxygen we breathe for respiration is a P block element. Whatever ore we mine for extracting any metal, they all exist either in oxides or sulfides or the nitrates, sulfates. Basically, they all are compounds of P block elements. We use electronic gadgets today in the 21st century, 20th century. They have revolutionized our life, and all these hardwares are made of P block elements. They are playing a major chunk in that, major role in that. We are getting today lighter cars because of aluminum, which is lighter but having a very high strength. All our electric isolators, they having a SF6 filled in that because of their high dielectric constants. These are just very few examples we have picked up to start P block elements. We'll start with group 15 elements, and group 15 is nitrogen, phosphorus, arsenic, antimony, bismuth. So we'll talk about these 5 elements only. The 6th element you can see is highly radioactive, and their life from chemistry point of view is not that important. To start with, we will talk about the properties of group 15 elements. Among the properties we will discuss atomic numbers. First, 7, 15, 33, 51, 83. So magic rule you remember, 2, 8, 8, 18, 18, 32, 32. So from here 8, 18, 18, 32. And atomic mass, it will increase. Now, electronic configuration, we know all these elements will have 5 valence electrons. So very first property we'll talk about is atomic and ionic radii. There is a considerable increase in covalent radius from nitrogen to phosphorus that we see here, 72 exactly 110 picometer. But from arsenic onwards, the radii increase is negligible, comparatively little or small. 110 to 121 only 11, then again only 21, 20, then from here only 7 picometer. Hardly any major increase in atomic radii. The reason is presence of completely filled d orbital and f orbitals in the heavier members. We know arsenic having a 3d orbital completely filled in that, it having a 4d, and this one bismuth even having a 4f orbital completely filled in that. The effect of these elements is d orbital having a very poor shielding, so the outermost electrons experience considerably greater effective nuclear charge. Because of this greater nuclear charge, outermost electrons are strongly or tightly bound to the nucleus, and that result in smaller atomic radii. We call it a covalent radii here because of presence of covalent bond between the atoms of group 15 elements. Now going to the bismuth, we see here is only 7 picometer increase. The reason is 4f electrons even having a poor shielding effect than d orbitals. So the effective nuclear charge experienced by the bismuth outermost electrons, these 5 electrons, is still stronger. That causes the electron to be tightly bound to the nuclei and results in smaller covalent radii. Going to the next property, ionization enthalpy. As there is a gradual increase in the atomic size down the group, ionization energy decreases. The ionization enthalpy of the group 15 element is much greater than that of the group 14 elements. The reason is we having here extra stable half-filled p orbitals. In their outer electron configuration we see it is a 2p3. We know p orbital having p subshell having 3 orbitals and having 3 electrons as well. So all 3 orbitals will occupy single electron. Half-filled configuration having extra stability that causes their ionization enthalpies to be higher than group 14 elements. We see here is a considerably high first ionization enthalpy, but it gradually decreases down the group because of increase in atomic size. Now next is electronegativity. As by definition we know, electronegativity is a capacity of an atom to attract electron toward itself. So it's a tug of war between the elements. The element or atom that can strongly pull the electron toward itself is more electronegative. For electronegativity, there is a decrease in the electronegativity down the size because there is the same concept, size increases. So as size increases, electrons are further from the nucleus. At that stage or in that conditions, the attractive force between the nucleus and the outermost electrons is not that strong. That is the reason down the group we saw decrease in electronegativity. But nitrogen is considerably electronegative compared to other elements. Now we will talk about the physical properties of group 15 elements. All the elements of this group except nitrogen are polyatomic, mean they exist in more than two atoms together. Nitrogen exists as a diatomic gas, while all other elements are solid. Nitrogen is gaseous. At room temperature, it exists as a gas, but all the rest of four elements, they are solid. For example, phosphorus, one of its allotropic form, exists as P4. Next is metallic character. Metallic character for these p block elements, group 15 elements, increases down the group. This is due to the decrease in ionization enthalpy and increase in atomic size. So with reduction in ionization enthalpy, electron having more mobility or freedom to move in crystal. So on that basis, we can classify the group 15 into three parts. First, nitrogen and phosphorus, which is non-metallic, purely non-metallic. There is a shift in non-metallic character to metallic character going through metalloids as we move down the group. Second part, it's a metalloid, arsenic and antimony. Third part, bismuth, which is metallic in character.